The Commodore Amiga is my favorite computer of all time. I grew up with it in the household and I just was in love with the system from the moment that I picked it up all the way back in 1988. Now the Amiga represents so many different things to so many different people. And the majority of the time when we think about the Amiga, we think about its incredible games. Now one aspect of the Amiga that I've always been fascinated about is making my own games for the Amiga. Now in the past I've done various ports of open source projects to the Amiga, but these were generally speaking things that didn't really take advantage of the Amiga's custom hardware, including the Blitter and the copper and the custom hardware, the custom chips found in the Amiga. They were generally ports from the PC and they required beefy accelerator cards, usually a 68040 or an 060. So I thought I would set myself a new challenge, and that is, can I build a game that runs on a stock Amiga 500? Well, at least with maybe 512K of expanded memory as well. But we're talking about a 7 MHz Motorola 68000 with just the custom chips to get the job done.
Now back in the day, this is what programmers had to work with, and this is what I love about this. Setting hard limits and boundaries makes you think outside the box, and to program a game to the strengths and limits and weaknesses of the target machine. This is very much a lost art form these days. And simply put, the days of bespoke hardware and programming for the machine are long gone. So why then build a game for the Amiga? Well, there's a few reasons. First, as mentioned, it's my favorite home computer that I just love. But more importantly, it's got a strong and passionate community that's building homebrew and games for this hardware almost every single day. In recent times, the Outrun port by developer Reassembler and the work that was done by Geezer Games, who has worked on various arcade ports, really inspired me. But other developers such as Rob Smith Dev, who builds games using Amos, a basic variant for the Amiga, and his thorough explanation on how to build games really were the main catalysts. The strong Amiga community I mentioned is also backed by loads of information and documentation and extremely talented people who are comprised of hardware experts, emulation experts, demo scene coders, game crackers, game developers, all having very intricate knowledge of the hardware. And with my years of software development experience, I gave myself half a chance to build something cool and interesting. I set myself the following goals. This would be my very first attempt to build a game on the Amiga that hit all the custom chips. The target would be a stock Amiga 500 using the original chipset, or OCS, with just 512 kilobytes of chip memory, with possibly an additional 512 kilobytes of RAM in the trapdoor expansion if memory started to become an issue. And that's it. This is about the lowest common denominator as possible. Now, while I have worked on some small basic demo style effects for the Amiga, I've never built a game from scratch, and this would be a fun challenge. Can I do it? Well, let's go ahead and find out.
So I had the idea to build this Amiga game, but the question now is, what kind of game do I want to build? And this is the difficult part of this process, because it's easy just to say, hey, I'm just going to build a game of Tetris or a game of Breakout. But if I'm going to build a game on the Amiga, then it's going to be something that I enjoy myself, that I want to play, that I'd be interested in seeing. So I decided to take a look at the various arcade games that kind of were around the 1982-1983 era, because that's kind of the sweet spot for a game, that would run well on a stock Amiga 500. And, it's a game, or those types of games back in those days didn't really have much in terms of colors. They had kind of limited color palettes, limited processing power, and limited, sprite hardware. But this was something that I thought would be a good kind of first step. So I decided to take a look at the various arcade ports that were already out for the Amiga and the ones that weren't available. And I settled on a game known as Zippy Race. Now, Zippy Race is a really fun arcade game from IREM that released in 1983.
In the game, the player controls a motorcycle and must travel from Los Angeles to New York City. The game has 5 individual stages. The first part uses an overhead point of view, and with each car that you overtake will cause the player's rank to increment by 1. The current rank is shown on the bottom right hand corner of the screen. The second part uses a third-person point of view in which the player must avoid cars that are coming at you from the opposite direction. If you reach the city without running out of fuel, you will be awarded bonus points and your fuel will be partially replenished, and then you'll set off on the next stage. It's a very fun and addictive early arcade game that saw ports to various 8-bit systems, including the NES and Sega SG-1000. Later on, an arcade port would show up on the Sony PlayStation. I used to love this game as a kid, and it's one of my very first arcade experiences, although at the time I could never get past level 3. Revisiting this game all these years later was done in MAME, and it was quite interesting. Rather than wanting to play it, I studied it, looking at the main sprites and cars, capturing some screenshots, and exploiting the tile sheets in MAME to get an idea about how many colors it needed. To be completely honest, I wasn't really sure how many colors I would need. I ended up importing some of the frames into Personal Paint, a very handy Amiga Paint package that would end up being used quite a bit in my development process. Long story short, it ended up being a good match for me to do my first Amiga game on, and I decided that Zippy Race was the game. Another goal that I set myself is that I did not want to use Amos, Blitz Basic, or something like the Scorpion Engine, Red Pill, or any other game maker. Now there's nothing wrong with any of these options, I just wanted to write the code myself as low level as possible, and for this I opted for using C instead of assembly. Now this was for a few reasons. First of all, I'm experienced in C so much more than assembly, and there are some excellent resources that I can study. I ended up following a YouTube series known as Amiga Programming in C that really got me inspired to write my own code. And second, C compilers on the Amiga are very well optimized these days, to the point where things like scene demos and games are running close to or even at the same speeds as equivalent assembly language. The gap between C and assembly on the Amiga is much more narrower than it once was. So how do we begin a project like this? Well, first, it must be said that we don't use original hardware for this, at least not yet. Original Amiga hardware can and should be used during testing, and certainly before release on as many Amiga configurations as possible. But for this, everything will be done on a PC. All we need is a compiler and an emulator to test. However, this is not very convenient for me. I didn't want to spend hours messing around trying to set up my own toolchain and cross-compiler to push code to WinUAE and have it crash without being able to debug and set breakpoints. Fortunately, once again, the Amiga community has solved this. I'm using the excellent Bartman Abyss Visual Studio one-stop solution to debug and profile Amiga C and C++ programs, and it does everything that I'm looking for. Running the sample program that comes with the installer shows the power of this toolchain. Not only are we using C, what makes it so cool is that it has excellent profiling and debugging tools.
Now when it comes to starting a project like this, it's very easy to get overwhelmed and daunted, especially when you start to consider all the parts to building a game like this. If you look at a game like Zippy Race, there is actually quite a lot going on, even though it's a very, very simple arcade game. But if you take a look at the gameplay, you can notice a few things off the bat. First of all, you've got a scrolling background. You've got at least 4 or 5 cars on the screen at any given time. You've also got this 3D intro sequence. There's also the status displays, the high score table. There's a lot that kind of goes on into this, and a lot of this stuff is pretty easy to implement, but orchestrating all this to kind of work as it would in the arcade version is quite challenging. So for me, what I really decided to do was just kind of start with a really basic thing, and that was, can I draw the motorcycle sprite on the screen without any background or anything else? Just get the motorcycle rendering on screen. That would be a good first step for me.
There's a few different ways to display bitmap graphic data, and to display the motorbike, I had 2 choices. It was either using the Amiga's Blitter or use Sprites. Now let's go into some detail about the differences between both. The Blitter is one of 2 coprocessors in the Amiga, and it's used to copy rectangular blocks of memory around at extremely high speeds. When data is being copied around, the Blitter is twice as fast as the 68000. But the best part is, the 68000 isn't used at all. This sounds ideal for moving graphics around quickly, especially sprite data. However, Blitter objects, or BOBs as they are called, are written directly to the Amiga's graphics memory, but since Blitter can only draw a rectangular area, it means it also draws the background behind it as part of the blit. So if a game has a background, which Zippy Race does, it means the background must be continuously redrawn. Therefore, we must pass in the blit object data and a 1-bit plain mask for that object, and when the mask is not set, we pass in the background data. This is also known as a cookie cutter blit and is used in many Amiga games. So we could use the blitter to draw the motorcycle object and animate it. But we also have to consider other objects such as the cars. In Zippy Race, I counted a total maximum of 5 cars moving on screen at once, and the main bike sprite, which means in the worst case, we would need to perform up to 6 cookie cutter blits every single frame on a scrolling background, which also requires the blitter. All this on a stock Amiga and maintain 50 or 60 FPS. Now my initial thought was that this would be too much for an Amiga 500. Now to be clear, this was not based on anything other than my various experience playing old retro Amiga games from back in the day. All of them seemed to run really sluggish. It turns out that many of these games weren't really built with the Amiga strengths in mind, and I was actually wrong. The blitter is what actually sets the Amiga apart from other home computers. A single cookie cutter blit of a 32x32 object with 4-bit planes will require around 4100 cycles. So if you do some simple math and divide this by 7.09, which is the clock speed of the Amiga, we get around 578 microseconds. To blit 6 objects that are 32x32, we would only need about 5 milliseconds, or around 20% of any given frame. Now of course, this is before any other CPU processing to handle logic, audio, and other things such as updating the HUD with data, but this seems like we're in the safe zone for this game to run at full speed. Now for the motorbike, I ended up using Amiga hardware sprites. On the Amiga, you can have up to 8 sprites, but they can only be 4 colors, which seems very limiting. Furthermore, each sprite can only be a maximum of 16 pixels wide, but they can be any height. But the best part is, there is no overhead with hardware sprites at all. So if I render a sprite on screen and then I move it around the screen, it adds 0 milliseconds to the frame time. Pretty cool, huh? Sprites can be attached to increase the number of colors. They can also be attached to increase the width of those sprites. You can even do both at the same time. But keep in mind, a 32x32 pixel sprite that requires 16 colors will require 4 Amiga hardware sprites, which means you've already used up 1/2 of the capacity of the total amount of sprites available at your disposal. Now you might be wondering, why would anyone even bother to use Amiga sprites? The thing is, what makes the Amiga so great is that in conjunction with all the other hardware features that you have at your disposal, it's all about finding creative ways to get the job done. I would argue to say that Amiga sprites are quite versatile in what they do. Once you can get over the shortcomings and limitations, they can be quite powerful. So for my motorcycle object, I would end up using Amiga sprites. What I found out was the bike sprite and its movement animation frames would fit neatly inside a 16x32 sprite. There are other animation frames, of course, when the sprite spins out or when it hits another car, but we will come back to these later. For now, I just wanted to render a moving bike sprite with animation frames for left and right turns. We said earlier that Amiga hardware sprites can only have up to 4 colors per sprite. This isn't ideal. However, it is possible to attach sprites and get access to 16 colors. Another thing to consider with this port was which Amiga screen mode would I use. The original game runs in a vertical or tate mode with a resolution of 240x256 pixels. On the Amiga, the 320x256 pixel PAL screen mode with 4-bit planes would be the ideal choice. The main game viewport only requires 192 pixels, and it maps nicely to the Amiga, with the remaining pixels used for the right-hand side HUD. So it was time to get to work. The first thing that I did was rip the motorbike sprites. I did this by capturing various animation frames in MAME and then cutting out the sprites using a sprite on Windows and creating a sprite sheet. Now this is a PNG with thousands of colors, so I loaded this sheet into Personal Paint on the Amiga and reduced the colors to just 16. Once I had reduced the sprite sheet to just 16 colors, I saved it as an interleave file or IFF image. I then exported this out as a raw data image and saved the palette. From here, I read some tutorials and this handy book on Amiga programming about how to render sprites on screen. It took a little bit of time to set up a simple copy list and set the color palette, but it wasn't long before I had this up and running. I then wired up simple joystick movements and an animation frame when the fire button is pressed to simulate the acceleration, and the bike sprite seems to work quite nice. Again, I do have to consider other animation frames when the bike spins out and crashes, but adding these later shouldn't be a big problem.
Now the next thing that would really make or break this project, whether I kind of had the chops to do this kind of project, is the scrolling background. Now the scrolling background in Zippy Race runs at full frame rate. We certainly want full speed scrolling on the Amiga. We don't want that jerky 25 FPS scrolling in this game, because I think that would really take away from this gameplay. So how do we do smooth scrolling on the Amiga? And that was something that I just went down a huge rabbit hole to try to figure out. But the great part is I was able to get out of it successfully.
I wanted to ensure that background vertical scrolling was as smooth as possible. Anything less would not be good enough. Now again, many Amiga games have vertical scrolling, but many of them aren't very smooth. Consider a game like Xenon 2 by the Bitmap brothers, for example. It's really poor when it comes to screen refreshing. This is because there are far too many blits being performed in a single frame, and this can really hurt performance.
And now, you don't really hear me, but I'm pressing the left mouse button there now, and it has drawn every single tile in the foreground of the game, which is just ludicrous, really.
On the other hand, there are some very good examples of 8-way smooth scrolling at 60 frames per second with lots going on screen at once. So I knew it was possible, but my beginner level Amiga coding skills made me feel a bit intimidated. But I decided I would give it a try. Let's think about how you would scroll an image vertically on an Amiga. If we're assuming a 320 by 256 bitmap at 4-bit planes, in order to simulate scrolling, the most obvious approach is to just reconstruct the entire frame with the new tiles that were brought in. But performing full screen blitz like this is not optimal, far from it in fact. We could consider using a double buffer approach where we prepare the tiles on an off-screen buffer and then flip the bitplane pointers around. That may be a little bit faster, but ideally we don't want to perform a full screen blit for every single frame. Fortunately, there is a classic Amiga hardware scrolling trick for smooth vertical scrolling that uses 16 by 16 pixel tiles, and this is the fast vertical scroll method that's used on many high performance Amiga games. For buttery smooth 1 pixel vertical scrolling with a 16 pixel tile, we stack 2 bitmaps in memory. We start by showing the top of bitmap A, and then we use the hardware scroll registers for smooth pixel by pixel movement. When we reach pixel 15 on the next frame, we instantly jump the bitplane pointers down 16 lines. The 16 pixel incoming row that we pre-rendered at the top of the current bitmap suddenly becomes the new top of the screen. The other bitmap is now off screen, so we update the bottom 16 line strip with the next row of tiles, and we rinse and repeat. Now what's interesting about this approach is that if we're assuming a 320 by 256 screen with 4 bitplanes or 16 colors, we need 2 copies of this bitmap. We also need additional rows before and after. Therefore, we need a 320 by 576 pixel bitmap, and to blit the incoming tiles we will need 20 separate 16 by 16 blits per bitmap, which means a total of 40 blits. Now this sounds like a recipe for disaster, does it not? Performing 40 blits sounds like the Amiga would slow down to a crawl. But remember, we are scrolling 1 pixel line per frame, right? So we have a total of 16 frames to sort out those 40 blits before the next lot comes in. So we just distribute those 40 blits across 16 frames to keep things running as fast as possible. And this process works quite nicely. Over on AmiNet, I tried out an excellent tutorial with source code, and as you can see, this scrolling is very smooth. And by disabling the bitplane pointers offset, you can see how the individual tiles are being pulled in and blitted per frame. Now there's even a more advanced way of doing this for extra performance, which involves using the Amiga's copper to manipulate the bitplane pointers when a certain scan line is hit, and this only requires half the blitz and does not even need a second screen. This gives even more performance and saves on valuable memory as well. Now this is definitely more in the advanced section, and it's something that I have not implemented in my codebase yet. But as it stands, once I implemented my tile maps, you can see that I have the first level of Zippy Race up and running with extremely smooth scrolling. As compared to the arcade, this is about as good as it's going to get, and I'm very happy with the result here. Now of course, as I continue to implement the other functionality in this game, the performance may suffer, but I still have the advanced scrolling method up my sleeve just in case I need to use it. Now a word on how I was able to construct the tile map and tiles for the game. I do want to point out that I've only constructed enough tiles for the first level, and this was something that took a few hours of my time. I looked at the various tools to rip tiles, including MAME, but the tiles that are exported from MAME were all 8x8 tiny blocks, which is like trying to put together a jigsaw puzzle, so I quickly gave up on that approach. What I did instead was take screenshots of individual areas of the first level in MAME where the road narrows and widens, where the road split and remerges, capturing as many 16x16 tiles as I could. I was able to fill up a 320x288 pixel tile sheet, and then I saved that as an IFF image in the Amiga with 4-bit planes. But then I had to figure out how to create a tile map. Now, I could use something like Tiled on Windows, which is certainly a very capable solution, but it didn't really seem intuitive for the Amiga. I needed something more visual and something more Amiga focused, so I turned to a tool called PowerCrawler. This tool is perfect for my needs, and although it's a native Amiga application with WinUAE at the fastest speeds, it loads extremely quickly. To set up my tile maps, I simply gave it my tile sheet and defined the size of the map, and from here I can visually reconstruct the tile map, then export it out to my code, which can load it and render it very quickly. Now I did have a few false starts as I was learning my way around PowerCrawler, but it didn't take me that long to reconstruct the first stage from Zippy Race.
Now, as I started developing the code for this project, I quickly realized I had a huge problem when it came to the HUD, which is the status display that's on the right-hand side of the screen. When we talk about blitting, doing full screen scrolling using the Blitter hardware and manipulating the bitplane pointers, then it's also implied that anything that is drawn on the screen will scroll up the screen with it. So we certainly didn't want the HUD to scroll up the screen along with the gameplay itself. So we needed to come up with a way to kind of keep the HUD static and scroll the rest of the screen as normal.
In Zippy Race, the HUD on the right hand side shows the current status of the game, including the score, ranking, distance, and the fuel gauge. I quickly realized that I had a problem. With the fast scrolling method by changing the bitmap pointers, how could I keep the HUD static on the right hand side? If we drew it into the bitmap, it would also scroll up, which is not what we want. But we could blit the HUD every single frame, but this doesn't sound very efficient. And I think this is the approach of how many games did this and why some games scroll so poorly. Games such as 1943 just have really bad scrolling. Another game that has really poor performance is The Last Duel. You can see here it gets really choppy. To solve for this, once again, we can use our old friend Amiga Sprites to build our HUD. But how do we do this? Well, so far, we've said that we've only used 2 sprites for the motorcycle, which means we have 6 available. We said that sprites can be 16 pixels wide, but they can be any height. The HUD in Zippy Race is 64 pixels wide, so what we can do is use 4 sprites. This means the HUD will not be affected by bitplane pointer adjustments and there will be no overhead. And we can also just focus on updating the parts of the HUD that need updating, rather than set every single sprite every single frame to save on additional frame time. I then created another tile sheet specifically for the fonts in the game. Once again, I ripped these from MAME and loaded it in. I created a simple map to reference each of the blocks and built some helper functions to draw strings. Remember, we're using 4 sprites, so I have to keep track of which sprite will be drawing data. In some instances, we need to render strings across 2 or more sprites, but because they sit side by side, this isn't an issue. Right now, the font is rendering only in 1 color, but as we said earlier, Amiga sprites can be up to 4 colors, so we can apply a color to the parts that need them later on. And the result is, we have our HUD and our scrolling background independently. Like I said, Amiga sprites often get criticized for being too limited, but it's all about how you use them, and in the end, I'm pretty happy with this.
So I hope you enjoyed this look at how a Amiga port is kind of taking shape. Obviously this is nowhere near finished, but I have a little bit more footage to show you guys. I did implement the intro sequence, the attract mode, and the 3D sequence as well in the game, which is something that we'll be using in the Zippy Race game itself during the stages. So more work has been done, but I'm going to leave that information for a follow-up video that I'll probably be doing sometime early in 2026. But hey, if you like these styles of videos, these development videos, please let me know. I'm more than happy to do more of these. I get really excited about this kind of content, and hopefully you guys do as well. But we're going to leave it here for today's episode. Thank you so much for watching. If you liked it, please don't forget to leave me a thumbs up, and I'll catch you guys in the next episode. Bye for now.